2.1, rectangular coordinates and graphs. Example 1 says if point AB is located in quadrant 2, find the quadrant of each of the following. All right, now this question is deceptively tricky. It looks like it's going to be super easy, but it's actually kind of tough because people read it wrong. When you see this right here, you don't want to think of it as a negative. All right, that does not say negative number. All right, it does not say negative. It says the opposite of whatever A was. So you got to look and be really careful. So it says if point AB is located in quadrant 2. So think about it. If you've got some point over here in quadrant 2, okay, let's just put it right there. Okay, quadrant 2. I don't care what the numbers are, but you should notice that the x coordinate is negative and the y coordinate is positive, correct? Yes, right? Yes. Okay. So what I want you to do is just write down right here. This is negative and this is positive. Okay. Whatever A is, it's negative, and whatever B is, it's positive. That's how it ended up in quadrant 2, correct? Okay. So when you look at part A, it says the opposite of A, comma, B. So forget about numbers. I don't care about numbers. Just think about the signs. A started out as what? Negative. So this says the opposite of that, meaning it is positive. Okay, so that means this is positive. And then B is just the same thing. So since B started out as positive, same thing, B, positive. Okay, so where are we at if we're positive, positive? Quadrant 1, correct. Because we know positive, positive is in quadrant 1. Okay, so then part B says A, comma, opposite B. It's really hard not to say negative B. I wanted to, but it's not negative. It's opposite of B. Okay, don't think of it as negative B. Think of it as opposite B. All right, so what did A start as? A started as negative. This just says use the same thing. A is negative. Then we've got opposite B. So what did B start as? Positive. So opposite B would be negative. We're negative, negative. And where are we if we're negative, negative? Negative, negative is in quadrant 3. This must be Q3. Okay? It's not that bad if you know how to think about it, but people really struggle. Next one says opposite A, opposite B. So just switch them both, right? Switch them both. A was negative, so now it's positive. B was positive, so now it's negative. Where are we? Positive, negative. Go X positive, Y negative. That's quadrant 4. You know how to make a 4 in Roman numerals? You can use the number 4 if you want. Doesn't really matter. Okay, now this is the one that throws everybody for a loop because they're jumbling it all up, okay? But just pay attention to what it says. It says opposite B, comma, A. So the first coordinate says opposite of whatever B was. So what was B? B was positive, so we're opposite of that. We are negative. And then the second coordinate is A, and it's just the same thing. So what was A? Negative, we're negative. That's negative, negative. Okay? So where are we if we're negative, negative? Quadrant 3. Okay? Just pay attention to details. That problem's not that bad, but I know students struggle with it. Okay? It's kind of tricky. Distance formula. I know you've seen this before. Square root of quantity x2 minus x1 squared plus quantity y2 minus y1 squared. We're finding the distance between 2 points. And that formula looks like it's super confusing, but if you really think about what it's doing, okay, I'll show you a shortcut, and I think I can make it a little bit easier. All right, so example 2 says find the distance between those 2 points. So notice you've got an x and a y and an x and a y. So the distance formula says square root of, okay, quantity. Second x is -1 minus first x is 3 and squared plus second y is 3 minus first y is -5. So notice that's minus negative squared. Okay. So let's clean that up a little bit. We've got -4 squared. That's -4, and we're going to square that and get 16. And plus plus gives me 8, so we're going to square that and get 64. So we've got square root of 16 plus 64. That's the square root of 80. Okay? Square root of 80. Now here's what you're not going to like. We're going to have to simplify radicals. On the assignment today, they're not going to want the answer like this. They're not even going to want you to just plug it into your calculator and give me the decimal. It's 8 point something. They're going to want the simplest radical form. Okay? So I know students sometimes forget about that, but remember your square root. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, square root of 64 is 8, square root of 81 is 9, square root of 100 is 10. You should know all of those like the back of your hand. You should know them backwards and forwards. Okay, you've got to know those. So anyway, what you want to do is find not just any one of those numbers that goes into 80, but the biggest one of those numbers that goes into 80. Okay, in order to be totally reduced, you need to get all of the perfect squares out. And so you find the biggest one of those numbers that goes into 80. So I know that 4 goes in, but so does 16. Okay, and you can get out a calculator and you can verify it by like saying 80 divided by 16 is 5. Okay, so basically what you want to do is a factor tree, and you want to split it up and call this square root of 16 times the square root of 5. Square root of 80 is equal to the square root of 16 times the square root of 5. The reason we do this is because we know the square root of 16 equals 4. That answer is going to be 4 times the square root of 5. Okay. Now, I want to give you a shortcut here. Okay. Not for the second part, but for the first part. A lot of students get confused by this formula and they mess up the negative signs, so I want to show you a shortcut. And I think this shortcut makes a whole lot of sense. Okay. So watch. You're finding the distance, right? You're finding the distance. So what the formula does is the formula says, I'm going to find the distance between the x's and the distance between the y's. Okay, that's what we're doing. When you subtract them, you're finding the distance between. So what I'm going to do is I'm going to look at these x numbers and say the distance between 3 and -1. If you picture that on a number line, you go over 3 in the positive direction, 1 in the negative direction. That's a distance of 4. Right? And the distance between the y numbers, the distance between -5 and +3 is 8, correct? Okay, so notice what happens if you square those numbers. You got square root of 16 plus 64. It's the same thing. So basically, I just completely jumped over that first step. I don't really have to know the formula. Sometimes people get confused because the formula looks confusing, and there's all those, the y2s and the y1s and the x2s and the x1s and the squareds and the pluses and the minuses, and where does everything go? But all I'm doing is finding the distance between the x's and the distance between the y's. Okay, so I would highly recommend you learn that shortcut. I mean, don't be intimidated by the formula, but learn the shortcut too, and you can completely skip that first step. I'll show you another example here in a bit.